A cyclic quadrilateral is an inscribed quadrilateral, where the vertices are all on the circle. And there exists a special relationship between opposite angles in a cyclic quadrilateral. So let's start off by looking at angle B and angle D. Well, I know that the measure of angle D in terms of the intercepted arc is that it's always going to be half. That's the definition of an inscribed angle. So we have half arc ABC. We also know that its opposite angle B, since angle B is an inscribed angle, that's going to be half of its intercepted arc, which is ADC. And if I look at arc ADC and arc ABC, they form a full circle. So I could write over here that arc ABC plus arc ADC must sum to 360 degrees. But that doesn't tell us anything specifically about opposite angles. So let's see what happens if I added up angle D and angle B. So I'm going to say measure of angle D plus measure of angle B is equal to, I'm just going to substitute in, we have 1/2 arc ABC plus 1/2 arc ADC. Well, if I solve this equation for one of these variables, then I can substitute in. So using a different color, I'm going to subtract arc ABC from both sides. So now I've solved for arc ADC, and it's 360 minus arc ABC. So what I'm going to do is, instead of writing ADC, I'm going to write 360 minus arc ABC. So this is equal to 1/2. And actually what I'm going to do is I'm going to erase ADC. And I'm going to write parentheses 360 minus arc ABC. So we still have D plus B is equal to 1/2 arc ABC. And distributing this 1/2, half of 360 is 180. Minus, because we have a positive 1/2 times a negative, minus 1/2 arc ABC. So if I combine like terms, positive 1/2 arc ABC, negative 1/2 arc ABC, those are going to add up to 0. So I see, I'm going to move over here, that measure of angle D plus measure of angle B is equal to 180 degrees. So in a cyclic quadrilateral, your opposite angles will always be supplementary. Another key facet of circles is if you have parallel lines. So what I'm going to do is I'm going to draw in a transversal. Something special is going to happen if I called this x degrees, and if I called this y degrees. I see that if these two are parallel, then I have created alternate interior angles that are congruent. And I see that I have an inscribed angle whose vertex is right here and whose intercepted arc is y. And over here I have an inscribed angle whose vertex is right here and whose intercepted arc is x. Now if these two inscribed angles are congruent, then x must equal y. So when you have parallel lines intercepting a circle, it will create two congruent arcs. So using these two facets of circles, we can solve for missing angles.